Hello and welcome to Chapter 3, Algebra 2 students. In this chapter, we're going to be dealing with systems of equations. Systems. So we're going to be trying to solve systems. That is the entirety of just Chapter 3. In 3.1, we're going to start with just one method, which is graphing. Okay, solving them graphically. It says with and without a calculator. All right, we're going to do a couple different methods here. The first thing that we should do is we probably should define what a system of equations is. So a system of equations are two or more linear equations that have the same variables. Okay, there will be two different variables. This is known as a 2x2 system, because there are going to be two equations, 1 and 2 there, and then they each have the same two variables. I have y and y, that's one variable, and I have x and x. So two variables and two equations make a 2x2 system. Feel free to write that part down right there. If I went too fast for you, pause, and then make sure you get those notes down. Now, in my example up here, what form are the equations in? Remember that we know three forms. We know point, slope, slope-intercept, and standard. Well, when I think back to standard, that is ax plus by equals c. I don't think that is what I have the top two in. Okay, well, I remember that point slope, that's a point in the slope. Okay, so y minus y1 equals m times x minus x1. I don't see any parentheses up there, so I don't think it's that. So these must be in slope intercept form. And what is that? That's y equals mx plus b. All right, let's think through this then. Well, I kind of just answered this question. It says, is that the only form we know? Of course not. I already named the other two, right, that we know. The other two. Of course, we could put the equations up there, 1 and 2, into any form that we would like. Now, it says here, can we graph the two equations on the same, keyword here being same, coordinate system? Could I actually physically graph them? Such as, let's go back up here, let's see if I can't get these equations. See if I can drag them down here for us. So I have this system right here, and I want to graph it on the same coordinate system. Well, I better make a xy there. And let's try to graph, I'll try a couple different colors here. I'll do this one here in green. Okay, so I have a intercept of 5, so I go up 5, 1, 2, 3, 4, 5 up here. And then I do my slope of -4, so down 1, 2, 3, 4, right 1. Then I draw my line. Well, all right, if I try to do the other one then, I think I'll do that one in purple. That's at -9. Okay, so I went down 1, 2, 3, 4, 5. I need to go more, so 6, 7, 8, 9. Be way down here. Slope of 3, 1, 2, 3 over 1. and then I attempt to draw my line nice and straight. Well, there I have it. Both of the equations graphed on the same coordinate system. On the same coordinate system. When I look at it, what do I see right away? What do I see? Well, when I look at it, the first thing that really jumps out to me is that it looks like they intersect right here. They intersect. Well, if it says what type of questions might we ask about the graph, things like, do the lines intersect? That seems like a logical question. Of course, in this case, it's yes. Well, then logically, the next question we might ask is where do they intersect? Well, this is a good point here. It's almost like I would have to guesstimate because I didn't exactly draw my line straight. So I wonder if it's going to be important now in this section that I draw my lines perfectly straight. Which, if you look up at the graph, I think it's rather clear. This is going to need to be drawn perfectly straight, not like I did before. Now we're going to have to use a straight edge when we graph these by hand. Now, what kind of possibilities could happen when we graph a system? On the last one, what did we have? On the last example, they intersected. Well, how many times did they intersect? Oh, that's in the second. They intersected. Well, how many times did they intersect? Well, they intersected once in the last one. Now, think about this. If they're straight lines, can they intersect twice, exactly twice, if they're straight lines? Well, we know this from geometry that two lines always intersect in a point. Okay, so one outcome would be that they intersect exactly once. Well, logically then, if they intersect once, then what if they just don't intersect? Do not intersect. That's got to be outcome number 2. The last one, this one's a little bit trickier to think through. Now, they can't intersect exactly once, but what happens if I graph the same line on top of the other one? So, line graphed on line. Meaning it's the exact same line twice. Well, that is actually the other situation that we might have. The other situation. How many answers, if they intersect once, do you think we're going to have? Number of answers. If they intersect once, there's one answer. If they don't intersect at all, there's no solution. And if it's a line on a line, then we say there are infinitely many for all real numbers. Okay, there are infinitely many solutions there. They're all real numbers. All right, we actually have words to describe these. We have words to describe these situations. So here, as I go down through, we're going to need to be able to classify a system. Classify depending on how many times a system has intersections. It is known as a consistent system if it has at least one solution. At least one solution. This is a great time to pause the video. I'm going to keep going. Pause the video so you can catch up. Inconsistent, then, is a system that has no solution. Okay, no solution. So this doesn't hit. doesn't intersect. This one is intersects. Okay. All right, let's keep going. Independent. This is when there's exactly one. So this is like our first example. Okay. Exactly one solution means that it's independent. And then the last thing you can probably guess it here is going to be a dependent solution or a dependent system which has infinitely many solutions. This is the line on a line. Okay, the same line graphed twice. This is a great time. Pause the video. Make sure you got time to write this down. I am going to continue as if you just paused the video on your own. Again, we're kind of working with our types of systems here. As we're looking at this first example, this is a great time to pause the video and copy down what I have up here. This system, when I look at it, has an intersection. Because it intersects, because they hit, it's consistent. Now, it hits exactly once, where I circled that. Oh, well, once means independent. So when I'm classifying this, if I ask for the classification of this system, you would say consistent and independent. Okay, consistent and independent. Let's look at the next one here. This one's a little bit tougher to kind of visualize here, but as I look at it, these two lines are meant to actually be on top of each other. These two lines right here intersect all along that straight line there, the whole way. So do they hit? The question is, do they hit? Of course, the answer to that is yes, they do hit. Since they hit, it's consistent, instantly consistent. Now, do they hit in one spot or more than one spot? Well, looking at it, they hit in a ton of spots. Well, that means that it's dependent. Okay. Now, what's left? We've done hits in one spot. We've done hits in a bunch of spots. The only one left to do is just if they don't hit, which are parallel lines. They're parallel lines. We've done this before. They don't intersect at all. So if I have a system that doesn't have an intersection, I would just say that it is inconsistent. Okay, it is inconsistent. Again, great time to pause the video, go back, make sure you're catching up, getting down the notes that you would like. Okay, you need to have everything caught up to this point before you go to the next slide with me. Now, this one says solve the system and classify the system as consistent and independent, consistent and dependent, or inconsistent. So we're going to do a few of these examples together. Again, now would be a great time to pause, make sure you get these directions down. Pause, like I do in class, or I have done in class before. Get your page set up so you're ready to do this example with me. Okay, now that you've had enough time to set your paper up, let's graph this. I can graph this equation I just started blue rather easy, right? It's just down to -6, put a point. Then I do my slope up to over 1, maybe I'll do it again. Maybe I'll do it one more time. And I can continue to do it, right? And now it's important that I actually draw a nice straight line. I need to make sure that this sucker is straight. So I'm actually going to use my little tool here to make sure it's straight. That looks pretty good for me for the blue one. Now I'm going to move on and I'm going to do this other one here in green. I'll start down at -3 like it wants. Then I go down one, right one, down one, right one, so on. And I know that you can kind of see it right now, but I'll still draw the line. Okay, I have it graphed. I just graphed them both. Hopefully you guys can graph it too. Now, my question is, do they hit? Yeah, it appears that they hit right there. How many times? Once. Okay, so hit once. All right, I know that hit means that it's consistent. And then I know that once means, okay, if it just hits ones, then I can only pick out one. That means they're independent. Okay, independent. All right. I think that covers the consistent independent. Okay, we did that. Now it did say, what's the solution? Well, this we haven't necessarily talked about. The solution is the intersection. Well, the intersection, I intersected, or I circled it in red there. What's that point at? Well, it would be over at 1, it looks like 1 for my x, and then I go down to negative 4. So my solution is a point, 1, negative 4. Now is a great time, pause the video, rewatch that one, okay? But we have done our very first example. Moving on to our second example here, okay? Second example, you should have it on your sheet too. Second example here. I am going to do the same type of thing. I think I'll grab the first one here in blue like I did before. So if I'm doing this one, this is a standard form. This is in standard form. So I use the cover-up method. If I cover up the y, I get negative x equals 6. Well, that's a negative 6. Remember that I want it as negative 6, 0. And then if I cover up the y, or the x value, I would have 2y equals 6. Well, that's a y of 3. That's 0, 3. Go over here, Graphically. We've done this before. Hopefully this isn't blowing anybody away. We have done this stuff before here. Draw my line. Again, I'm using the tool because I need it to be perfectly straight. This one's going to have to be perfectly straight. Next, I'm going to do my next equation here. Again, if you feel confident, you should pause the video, try to sucker out on your own. All right, I know that I'm supposed to start at 3. Okay, put my point down 1. I'm sorry, up 1, over 2. Up 1, over 2. So on. Draw my line perfectly straight. Uh-oh. What do I see here? This looks like it's intersecting in this whole big spot. It looks like it's the exact same line. Same line. Well, if it's the same line, do they hit? Yes, they're hitting everywhere. Well, that still means that it's consistent. Okay, if they're hitting more than one spot, that's when I use, dependent. The reason it is called dependent, the y value is going to depend on the x in this case. I can pick a bunch of different answers. Any x value I pick, I can find the y for that one. That's why it's known as dependent. And that's the second example. Again, great time. Pause the video, go back, make sure you're understanding how to do this. All these notes need to be down. I have example 3, and I think this will be the last one that I want to do with you. Okay, this will be it. This will bring the video up to 18 minutes here. I'll probably finish this one with about, it's probably in 20 minutes into the video. Okay, so let's see if we can't do this. I'll do the same type of stuff that I've done in the past here. Let's do this one right here in blue. Ooh, this is absolute value. How did I do absolute value last time? That's when I did the vertex at h comma k. Well, the h is at 1 and the k is at 3. So my vertex is at 1, 3. Okay, go to 1, 3, put my point. Then I use my slope-ish. The slope-ish is this negative 2. I have to go right. So I have to go down 1, 2, and then to the right one. Down 1, 2, and then to the right. Now I can draw that side of it. Remember though, this thing is supposed to look like a V. So I have to go down 2 and then left. Down 2 and then left. Again, I'm using the tool. I want these lines as straight as I possibly can get them. Okay, I want them very, very straight. After I have that one graphed, move on to the next here. Negative 4. Okay, negative 4 is down here. Up to 1, 2, right 1. Up 2, right 1. Up 2, right 1. Okay, now I got to draw this line as straight as I possibly can. Now, it did say I had to classify. It appears as though this hits right there. The question is, are these two lines, right here and here, are they going to cross or intersect again? Well, let's think through this. The slope of the green line is 2. Green slope equals 2. The left side of the blue has a slope. Okay, now I see the -2 out here. But remember, that's the right side. That's why you have to go right. The left side of the V there, that slope is actually 2. If these are the same, will they intersect? Well, you know, by definition of parallel lines, that actually the left side of the blue is parallel to the green. Oh, that means they won't intersect down in the corner. That means there's only this single intersection point. If there's only a single intersection point, well, it's intersected, so that's consistent. And if it's only in one spot, we say that that is independent. And now I need to pick out where that spot is. This is exactly why graphing is not perfect. It doesn't appear to me that that hits in a nice spot. It looks about like a third of the way past 2. It's like 2 and 1/3. And then I have to go up probably like 1/3 as well. And that is my solution. This one's a little bit trickier of a problem. Please pause the video, rework it, especially that part where I'm talking about the left side of my V and the green line being parallel. Okay. That completes the video for 3.1.